This is the Vika Academy. Today we are looking at transition matrix. Transition matrix is a topic in linear algebra which is very important. Remember last time we looked at transformations of matrix, linear transformations, and we saw how we generate matrices. If you have not subscribed to this channel, kindly subscribe right now and share also with your friends. Okay, we start with this theorem. We let P be a transition matrix from basis EI to EI prime in V, and Q be a transition matrix from basis Fi of to Fi prime in W. So we are talking about this linear mapping. So you're saying then for any linear mapping for V to W, for V is E basis, E basis, and for W is F basis. A transition from I's, I's is P, transition matrix for that, and transition matrix for Fi to Fi prime is Q, so that this becomes true. So this relationship that you need to keep in your mind, because you'll be applying it in various parts of linear algebra, not only in linear algebra but also in other parts of applied mathematics, numerical analysis, and so on. They all base the argument from here. So this will be true. Thus, it will imply that if you want to get E to E prime, then that becomes true. Basis on the change basis in W only, and for the changes in V only, we have this. We'll have that. Okay. Let's look at an example. We look at matrix representation of a general linear mapping, which is mapping this one, which is R4, which is our domain, to R3. R4, we say it means that we have four vectors in little vector. Then it is mapped to three vectors, and these are the products for those, the three vectors. Remember, in R4 we have E being the standard basis, and E prime bases are actually defined below. In R cubed, R3 is F is standard basis of R3, and F prime is actually this. Remember, when we talk about standard basis of E, we talk about 1, 0, 0, 0. We shift 1, 0, 1, 0, 0. We shift 1 again, 0, 0, 1, 0. We shift 1 again, 0, 0, 0, 1. That is now what we call standard basis. Standard basis of E. Standard basis of F will be 1, 0, 0, shift to 0, 0, 1, 0, shift 1, 0, 0, 1. So these are the basis, the standard basis of F. So when we are talking about that, I think now we are together, we can see that. Okay. Now, if you want to transform from previous tutorial that we did under linear transformations, it's easier for us to get this. It is easier for us to get that. Again, it is easier for us to have this. This one and this one, we are going to use the relationship as per our theorem that we have just noted here, so that will become true. Okay, so therefore, for example, if you want to get those vectors, we do TE1. TE1 is actually T. These are, remember, they are standard basis 0, 0, 0. What does this mean? It means that the x1 is 1 and others are 0. Others are 0. So that by definition here, our x1 is 1, x2 is 0, x4 is 0, x1 is 1, x3 is 0, x4 is 0, x3 is 0, x4 is 0. So that's the reason we have 2, we have 2, we have 2, so we have 2, 2, then next 4, because x is 1, 4 times 1, 4, 4, and the other one, x3 is 0 and x4 is 0, so that becomes 0, 0. So we'll have here 0. So this vector is actually 2, 4, 0, becomes a column. Substitute the next one, you get that third and fourth, and hence you have gotten this one. The next one, for this one, here we are substituting with E1 prime as defined in here, 1, 1, 1. So if you substitute that as part of homework, confirm whether you are going to get this. Remember, if you have any question on either of the point which you find not clear, kindly just leave a comment and I will be able to guide you on how we arrive to such answer. So the transition matrix, which is P, is transforming E1 to E bar. So from what we know is that it is actually what we call a lower bound triangular matrix. So a P is given by this lower triangular matrix with the ones on the lower side and zeros on the other side. This is what we call the transition matrix for this basis. P. Okay, transition matrix Fi for F bar. It's actually again a right upper matrix with ones on the upper side and zeros on the lower side. That is a transition matrix from base Fi to Fi bar. Note that P is lower, okay, and Q is upper like that. What we need now is to get the inverse of Q, inverse matrix of Q, as per our definition in our theory. So that we want our end product to be F1. So F1s are these ones. So applying the relation criteria, you'll find that that 0, that 0, that 1 is this one. That one, that one, that one is here. This, and that is actually here. And that becomes your inverse Q inverse. This is a matrix which is mapping a bar to Fi. So that now, from our relationship here, if we want to get Fi, that matrix from changing E base E to Fi, then we just basically need this relationship. So we know Q inverse is that, and we know T from E to F is actually this. If you open that, you automatically get that as the answer. Kindly work out that and see whether you are arriving to that. This is just from application of modification of matrices. Application of matrices. Okay. The other relationship is actually this. We want now to change from to have a matrix with E bar basis to F, changing from E bar basis to F. So what is happening here? So what we are doing here, we are taking T from E to F times P. P is that, and if you apply the operation of matrices, you get that is also true. Confirm that. If you have a question on the modification of this, I can also guide you. So just leave a comment on that. So that now we have this, we have P and we have inverse. That will transform your matrix to those E bar to F bar matrix. So if you open this, when that, you are basically going to get this being true, that being true. Okay, so if you have any question on either of the points here, kindly leave a comment and remember to subscribe and also to let your friends know that we have this channel which is helping us to know more about mathematics.